Okay, in this video we are going to do some multiple choice review problems. Most of them aren't going to have answer choices because to make answer choices is really annoying. So these aren't actual problems from actual exams, but they're spiraled or based on problems from actual exams. They're exactly the difficulty that you would need to be able to deal with. There's a link to the problems in the description, and in the problem set there's also links to the parts of the video where I go over each part of the problem. So get the problems, give them a try, and then come back and watch the parts you need to, or watch the whole video. All right, let's do these. Number one, the depth of the snow in inches that has accumulated at a measuring station at time t in hours, where t is measured in hours, is modeled by s of t equals 1/2 t squared plus 1/5 t plus 1/4 between 0 and 2. At what rate in inches per hour is the depth of the snow changing at t equals 1 hour? All right, so we could probably just answer this, but I'm going to show what I do when I'm confused on a problem. So if I'm confused and there are a lot of units involved, I try to draw something. So here, I'll just draw like whatever. It doesn't really matter if it's accurate or not, because I'm just using it to get a sense of the units. So that's my S of t. I know that S of t is measured in inches, which means this axis has units inches. And then time is measured in hours, so this will be hours. So for the problem, I'm looking for inches per hour. If you look at it, that's like y over x. So I'm looking for the slope of a tangent line. I already knew that, but I just wanted to show you when you do get lost in a problem, that's a technique you can definitely use, and it makes things a little easier. So I need to find slope of the tangent line, so the derivative. So this will be in inches per hour, and s prime of t is going to be just power rule your way through this, and then we're looking for s prime of 1. So that's going to be 1 plus 1/5, which is definitely 6/5, and that's in inches per hour. And so that's our answer. All right, let's take a look at the next one. All right, so this one does have answer choices because there's no way to write these problems without them. Shown above is a slope field for which of the following differential equations? All right, so a pretty common thing to do. I didn't make the numbers all that big there, but I see two horizontal kind of asymptote type situations, and then there's the x-axis, so you want to be able to distinguish those, which on the actual exam, it's a little easier to distinguish than on this. So the first thing I notice is that along horizontal lines, the slope is always the same. It doesn't change as you move along a horizontal line, which means that x is having no impact on the slope, which means that I can cross out any differential equation that has an x in it. So I'm going to cross out c, and I'm going to cross out b because they both have x's in them. All right, now I just have to choose between 2 minus y times 1 plus y and y plus 1 times y minus 2. So they're almost the same differential equation. Usually what I do is I look for 0 slopes. So here, when y is equal to 2, the slope is 0. But unfortunately, if you look at both of the differential equations, when y is equal to 2, both of them are equal to 0. So that doesn't really help. Maybe the other one will help. Here, this is when y is equal to -1, dy dx equals 0. But if I sub that in, I also get 0 for both of them. So those are my usual strategies. They didn't work, so I'm going to move on to another strategy, which is basically to pick a point. So I notice that if I'm up here when y is greater than 2, so anytime y is greater than 2, these all have positive slopes. So when y is greater than 2, dy dx is positive. In part A, if I take something greater than 2, so like 5, like option A, I should say, choice A, in A, if I take y equals 5, I would get 2 minus 5 is -3 times 6, which is negative, which doesn't fit the bill, so I can cross that out. And then just to confirm, in D, if I plug in 5, I would get 6 times 3, 18, positive, so that works. So D is the answer there. So that was multiple choice. Had to have the options, because otherwise, what question are you going to ask? All right, let's look at the next one. Oil is being pumped continuously from an oil well, from an oil well at a rate proportional to the amount of oil left in the well, meaning dp dt equals k times p, where K is a constant and P is the amount of oil left in the well at any time T, with T measured in years. So that's a crazy sentence, but basically what we get out of that is that dP dt is equal to K times P. And then we're told that T is in years, and P is the amount of oil. I'm just rereading it at this point. But all that really matters is dP dt equals K times P. Initially, there's 2 million gallons of oil in the well, and 5 years later, there were only 400,000 gallons remaining. Write an expression for P of T. Okay, so from the first part, we get dP dt equals K times P. You might actually have memorized the solution to this differential equation. I tend to solve it every time, just in case. I'm a little overcautious, I guess. So this is separation of variables. If you haven't done a lot of this, there are definitely other videos that can help with this. I always go from this, I'm going to say this is, on the left-hand side, it's dP over P. That's definitely a natural log. So natural log absolute value of P. And then on the right-hand side, it's going to be KT plus C. So the constant goes on the right-hand side with the independent variable. And then at this point, I always exponentiate and get rid of the absolute value and bring the constant down at the same time. So P is equal to CE to the KT. And like a lot happened there, so hopefully you've done these before and you can review that process or watch the videos and review it from there. So at this point, we just need to solve for C and we need to solve for K. So we know there's 2 million gallons initially, so that means that P of 0 is 2 million. I really regret choosing numbers that are this big. All right, so let's plug in. So 2 million is P of 0 is equal to CE to the 0, so C is definitely 2 million. Which means that now we're looking at 2 million e to the kt. All right, so we got to solve for k. So look at the rest of the problem. We know that at 5 years there are 400,000, so that's P of 5 is 400,000. So we just sub in again. So 2 million e to the 5k is equal to 400,000. All right, so divide, and we get this. I'm going to take the natural log of both sides, and then natural log of e to the 5k is just 5k. So 5k equals natural log of 1/5. Divide by 5. K is 1/5 natural log of 1/5. But properties of logs, coefficients become exponents. So I'm going to make this the natural log of the quantity 1/5 to the 1/5. Which is kind of a weird thing to do, but stuff's going to happen here. So I'm going to make my substitution here for k. So P is 2 million. So what I do is I move t to the front and do t natural log of 1/5 to the 1/5. And then we have another natural log, so a coefficient can become an exponent. So I'll get the t becomes the exponent of 1/5 to the 1/5, and then power to a power, you multiply the powers. So P equals 2 million e to the natural log of 1/5 to the t over 5, because 1/5 to the 1/5 to the t is 1/5 to the t times 1/5. There's too many 1/5s in this problem, but we end up there. And then we have e to the natural log of blah is equal to blah. That's a property of exponentials. So I get 2 million. E to the natural log collapses, and I get 1/5 to the t over 5, which is definitely the answer I would choose. But multiple choice, there's no way to know that somebody didn't make it 1/5 is 5 to the negative first. So 5 to the negative first to the t over 5 is 5 to the negative t over 5. That could be an answer choice as well. No way to know without the options. All right, let's take a look at the next one, which also has multiple choice options because, again, there's really no way to ask this without them. So we have a graph of f, a graph of g. Graphs of f and g are shown above in the figures, above. Which of the following is false? Okay, so I always have a problem with this because I tend to find the first true one and just pick it. So I'm going to underline false and try to really focus in on I want something that's false as my answer. And we have no choice but to kind of go through them. So for A, I'm going to do a u substitution. U is equal to x plus 2. So if x is approaching -1, then u is approaching +1. So this is saying the limit as u approaches 1 of f of u is equal to 2. So now I'm going to go to the graph of f and approach 1. So that puts me in this box, and you can see the y values are definitely approaching 2 as u approaches 1 or x approaches 1 or whatever. So this is true, which means it is not the answer because I'm looking for something false. All right, let's do b. Same idea. U is x minus 2. As x approaches 1, u is going to approach negative 1. So it's the limit as u approaches negative 1 of g of u. And the question is, does this not exist? So we go to the box, or we put a box around it so we can focus in on it. From the left, the limit is 1. From the right, the limit is 3. Limit from the left doesn't equal limit from the right, so the limit does not exist. So this does not exist, which means this is true, which means it is not my answer because I'm looking for something false. All right, let's do C. So C, I'm going to break up a little bit, right? So I have the limit as x approaches 1 of f of x, and then I'm going to do a u substitution for the second part and see if that exists. So I'm only allowed to break up a limit of a product if both limits exist. So this problem now becomes the limit as x approaches 1 of f of x times the limit as u approaches 0 of g of u. So I have to see if both of these limits exist. I already know that the limit as x approaches 1 exists because that was actually part A when I rewrote that. So that works. And then for the second part, go to the graph of g. From the left and the right, you're approaching 0, so that definitely exists, which means that overall this limit exists, which means that is true, which is not what I want, so the answer must be D. And the reason that it's D actually is the limit as x approaches negative 1 of g of x just doesn't exist. And the other part, so basically D is the answer to part A times does not exist. And so it doesn't exist. So it is false, and that is why that's our answer. All right, let's move on. Next. Okay. Let f be the function defined by f of x equals 2x cubed plus 11 halves x squared minus 10x. What is the largest open interval on which f is both concave down and decreasing? So this is a good problem. This is like a kind of like a starter question when you're first learning to take derivatives. So power rule here. I'm gonna have to factor that. I'm going to take the second derivative before I deal with that, because I know it's easier to take the second derivative from the non-factored form. So that's, again, just power rule. So let's go back and factor f prime. So I'm going to go with 2x and 3x, and then I think I'm going to go with plus 5 minus 2, which gives me 15x's minus 4x's is 11x's, so that works. Okay, so f prime equals 0. Gives me x is negative 5 halves, x is 2/3. I guess I should mention, if you can't factor that, you can use the quadratic formula. It'll give you the zeros, but it's easier to factor and a little quicker. F double prime equals 0 is definitely negative 11 twelfths, I should say. All right, so we'll make our stack sign charts. We're going to put the zeros of the first derivative, the zeros of the second derivative, put them in roughly the correct locations so that you can identify regions where things are happening. F prime is a quadratic that opens up, so you can fill in pluses, then minuses, then pluses, or test the regions. Plug in negative a billion, plug in 0, plug in a billion. F double prime is a line with a positive slope, so it goes from negative to positive. Or test the regions. So however you fill in sign charts, just get really good at it, get really fast. Okay, so concave down, decreasing is what we're looking for. So concave down means the second derivative is negative, decreasing means the first derivative is negative, which means we're looking at this part where everything was negative, so that's from negative 5 halves to negative 11 halves. Okay, is that right? I feel like that inequality goes the wrong way. Negative 11 halves. Oh no, negative 11 twelfths. That's why. What? I put the wrong thing on the number line. That's why that's a weird answer. So it's negative 5 halves to negative 11 twelfths, and that feels way better. I was having this issue where it's like negative 11 halves is definitely less than negative 5 halves, and blah, blah, blah. That should be negative 11 twelfths. So, if you're checking your answer, go with that. All right, next. Given that 4x minus 3 secant squared of y is equal to 3, what is dy dx in terms of y? So this is a weird question. Initially, you're like, in terms of y, how am I going to do that? Let's just do the problem and see how it ends up. So this is implicit. So I like to show this step. Actually, I like to forget to show this step. I should show this step because it will prevent me from making the most common error, which is to forget the derivative of a constant is 0. So on the right-hand side, we're just going to get 0. Number one mistake people make. All right, on the left-hand side, the derivative of 4x is 4 with respect to x. The derivative of negative 3 secant squared of y is kind of a chain rule problem, right? So negative 3 something squared, so it's going to be negative 6 secant of y times the derivative of secant of y, which is secant y tan y, times the derivative of y, which is dy dx. Okay, and then we said the right-hand side, definitely 0, derivative of a constant. I'm going to move everything over. So we'll actually collect a little bit, I guess. 4 minus 6 secant squared of y, tan of y, dy dx is 0. Now I'm going to move the 4, so subtract 4, divide by negative 6, blah, blah, blah. So I get positive 4 over positive 6 secant squared y, tan y, which definitely you could simplify to 2/3 and then that stuff. I think an answer choice might use sines and cosines. So secant is 1 over cosine, tangent is sine over cosine. So there's actually a lot of cosines here. Another way of writing this is 2 cosine cubed of y over 3 sine of y. So if that's what, who knows what the answer choice will look like. Definitely 4/6 would be reduced. I don't know, they might leave secants and tans. Hard to say. All right, let's look at the next one. For time t greater than or equal to 0, the position of a particle moving along the y-axis is given by y of t equals square root of t cubed plus 1. At what time t in the interval 1 to 4 is the instantaneous velocity of the particle equal to the average velocity of the particle over the interval from 1 to 4? So this feels like a mean value theorem question, but it doesn't say like apply the mean value theorem. So what it's really just saying is do exactly what's happening. The function wouldn't need to be differentiable. Don't worry about that unless a problem stipulates mean value theorem or like must there be a value, something like that. Just do the problem that you're given. So instantaneous velocity is going to be y prime. And then average velocity is going to be average rate of change, which is from 1 to 4. So that's going to be y of 4 minus y of 1 over 4 minus 1, which is 3. So I got to find y prime and then y4 and y of 1. So I'm going to do this over on the side. So y of t I'm going to rewrite as t to the 3/2 plus 1. Derivative of that is a power rule problem. So I get 3/2 t to the 1/2. And then y of 4, just by subbing in, you get square root of 64 plus 1, which is 8 plus 1, which is 9. And then y of 1, you get 1 plus 1, which is 2. All right, so over here we got 3/2 t to the 1/2 equals 9 minus 2 over 3. So 9 minus 2. Okay, so 9 minus 2 is 7, and then times 2 is 14, and then divided by 3 is 9. So I'm multiplying both sides by 2/3. So I get this, and then square it. So 196 over 81 is the value of t at which the instantaneous and velocity equals the average velocity on the interval from 1 to 4. So we answered the question. All right, let's take a look at number 8. If f is a differentiable function and y equals cosine squared of f of x to the 4th, what is dy dx? When x equals 2, I forgot to do that part, you'll see at the end, but we could probably fix that. Okay, so I just got to really focus on finding dy dx. So y is equal to this. All right, so it's basically something squared, right? The derivative of something squared is 2 times that thing. So it's going to be 2 times cosine of f of x to the fourth times the derivative of that thing. The derivative of cosine of something is negative sine of that thing. So negative sine of f of x to the fourth times the derivative of that thing. That thing is f of something. The derivative of f of something is f prime of that thing times the derivative of that thing. The derivative of x to the fourth is 4x cubed. All right, so what I'm going to do is clean this up. Just, 2 times negative 4, it is negative 8, and then x cubed. And then all of this. Then I guess I didn't really answer the question. So if it was really multiple choice, I would have noticed that because all the options would have had just numbers, like numerical values. So basically, 2 cubed is 8. So this will be negative 64. Cosine f of 2 to the fourth is 16. Sine of f of 16, f prime of 16. So that would be the final answer. I forgot to substitute 2, and I don't want to take the time to write it. All right. So let's take a look at number 9. The graph of h prime, the first derivative of the function h, consists of 2 line segments and a semicircle of radius 2, as shown in the figure above. If h of 4 equals 3, what is h of negative 2? All right, so if you're given a graph of the derivative and you're asked about values of the function, this is almost always a fundamental theorem question. So I'm going to write down the fundamental theorem using negative 2 and 4 and h prime. So I know that the integral from negative 2 to 4 of h prime of x or t or whatever, dx is h of 4 minus h of negative 2. And I know that h of negative 2 is h of 4, I'm just rearranging this, h of 4 minus the integral from negative 2 to 4 of h prime of x dx. So h of 4 was given, and the rest of it we can kind of do geometrically, right? So I need to go from negative 2 to 4. So first this triangle, which has a base of 4, a height of 3, and therefore an area of half of 12, so 6. And then this, it's a quarter of a circle, we're going from 2 to 4. So it's a circle of radius 2, which in total would have an area of 4 pi. We want 1/4 of that, which is pi, but it's below the axis, so negative pi in this region. Okay, so this will be 3, which we were given, and then minus the quantity 6 minus pi, right? Because as we go from left to right, we pick up 6, then we lose pi, so 6 minus pi. And then overall, this is pi minus 3. All right, so that one was actually pretty straightforward. And one more, so number 10. Let f be the function given by f of x equals x cubed minus 9x squared plus 24x plus 2. What is the minimum value of f on the interval from negative 1 to 5? All right, so it's a closed interval, which means we're basically doing the candidates test, which actually might be my favorite test to do because it's like very organized. So it's not asking me to justify it, but I mean the function is continuous, therefore by candidates test, the absolute max and min occur at an endpoint or a critical point, but we don't have to write that because it's multiple choice in theory. So I'm going to find the critical points, which means I need the derivative, which means use the power rule. So 3x squared minus 18x plus 24. We can factor a 3 out and make our lives easier. 3 quantity x squared minus 6x plus 8. Got to factor this, that's 3. So go x and x. I'm thinking minus 2 and minus 4 gives me 8 and adds up to negative 6. So 2, negative 4. So now I know my critical points are 2 and 4. My endpoints are negative 1 and 5. The most common mistake is to forget the endpoints on this. I see a lot of my students doing that. So let's do negative 1, 2, 4, 5. And now we just have to substitute in. So to plug in negative 1, it's going to be negative 1 minus 9 minus 24 plus 2, which if you add that up, you get negative 32. At 2, you're going to get 8 minus 36 plus 48 plus 2. If you add all of that up, so you get 58 minus 36, so 22. At 4, you're going to get 64 minus 144 plus 96 plus 2. Okay, so that's negative 80, and then 16 and 18, so 18. And then at 5, this is just annoying arithmetic at this point. 125 minus 225 plus 120 plus 2. So you get negative 100, and then 20, and then 22. Okay, so the question was the minimum value. So the minimum value you can see from the table is negative 32. And that's the final answer. All right, so that's 10 more questions that look like multiple choice questions from the AP exam. We didn't have answer choices for all of them, but this is how I'd go through and solve them. I hope you found this helpful, and good luck.